The supermassive black hole at the center of our Milky Way. The mystery of the supermassive black hole at the center of our Milky Way has finally been solved. Released after years of research, the world has been gifted with the second photograph ever of a supermassive black hole. The scientists at the Event Horizon Telescope, or EHT, released this first image of Sagittarius A star, the supermassive black hole at the center of our galaxy. This was another major announcement after the first image of a black hole was announced in 2019. So let's learn more about the details of this important announcement. For years, supermassive black holes have been a mystery. How these supermassive black holes were formed in the early universe is still a mystery that astronomers are trying to figure out. Scientists have long believed that a supermassive black hole deep in our galaxy's chaotic central region was the only possible explanation for the strange things that occurred there, such as giant stars slingshotting around an invisible something at a significant fraction of the speed of light. However, they have been cautious to declare so explicitly. When astronomers Reinhard Genzel and Andrea Ghez received a portion of the 2020 Nobel Prize in Physics for their work on Sagittarius A star, their citations said that they were honored for discovering a gigantic compact object at the center of our galaxy, not the finding of a black hole. But that is a thing of the past. Because black holes devour everything that falls into them, including light, they are effectively invisible. However, they twist space-time around them so drastically that they cast a shadow when lit by brilliant streams of infalling matter, torn in their gravitational grip. The shadow is around 2.5 times bigger than the event horizon of a black hole, which is its border and distinguishing feature, the line in space-time through which nothing that passes can return. This celestial gift comes from the same object that made headlines in 2019 when it unveiled the first picture of a black hole. That now iconic hazy orange image depicted a supermassive black hole at the center of Messier 87, or M87, a large galaxy 55 million light-years from Earth. The groundbreaking discovery assisted scientists in verifying the circular form of these objects and further confirmed Albert Einstein's theory of general relativity, which predicted the existence of black holes. Now the crew has returned with another image of a black hole, this time in our own backyard. Sagittarius A star, or SGR A star, is considered to be around 4 million times the mass of the Sun and is located approximately 26,000 light-years from Earth. For decades, scientists have deduced its presence at the center of our galaxy based on how things travel about it. However, this is the first time we have direct view of its dark core portion, or shadow, providing further evidence of the nexus of our cosmic neighborhood's existence. We didn't have a direct image indicating that SGR A star was a black hole until today. This picture depicts a brilliant ring encircling the blackness, a telltale indicator of the black hole's shadow. Black holes, by definition, cannot be seen since they are so huge that nothing, not even light, can escape their gravitational attraction. Instead, we can capture a black hole's silhouette. If a supermassive black hole is surrounded by a spinning disk of gas and dust, that material will shine brightly because the gas and dust are sped up and heated by the neighboring hole's enormous gravitational attraction. EHT truly captures the black hole's shadow against the backdrop of blazing gas and dust. With each new image of a supermassive black hole, scientists learn a little bit more about these mysterious monsters. The EHT uses a method known as Very Long Baseline Interferometry, or VLBI, which unites radio observatories on different continents to build a virtual Earth-sized telescope, an instrument with the finest resolution in all of astronomy. The EHT collaboration spent several nights in April 2017 aiming that virtual instrument at Sagittarius A star and other supermassive black holes. The first final result of that work has already been seen in Messier 87. During the same campaign, the team collected raw data for the Sagittarius A-star photograph. But turning those observations into an actual image took significantly longer. That's because Sagittarius A-star is ever-changing. M87 star, the black hole in the center of the galaxy Messier 87, is so massive that it takes many hours for matter swirling around it to complete a full revolution. In practice, this means you may gaze at it for a long time and it will hardly alter. Because Sagittarius A-star is 1,000 times less massive, it changes 1,000 times faster as matter flows in tighter, faster orbits around the black hole. Matter moves so swiftly around Sagittarius A-star that it alters minute by minute. It's difficult to take a time-lapse image of a speeding bullet. As a result, getting a clear picture of Sagittarius A-star from the data gathered during the 2017 observation has taken many years. The mercurial nature of Sagittarius A-star makes it difficult to view, but it also makes it an interesting laboratory for future investigations of black holes and Einstein's general theory of relativity, his renowned theory of gravity. Astronomers already knew Sagittarius A-star's fundamental parameters, including mass, diameter, and distance from the Earth, to remarkable accuracy from decades of long research with various telescopes. They can now, at long last, see it evolve in real time, as it feeds on flaring, flashing streams of stuff. Taking photos of these black hole shadows, on the other hand, is a difficult process. According to the Event Horizon Telescope project, a single telescope the size of planet Earth would be required to acquire an image like this of Sagittarius A-star. Because making such equipment isn't quite feasible, scientists developed a workaround. Observing this black hole requires peeking through the Milky Way's galactic plane and all of the gaseous stuff in between us and the black hole. This causes a great deal of interference, which the scientists had to work around. The EHT is a massive network of radio dishes stretched over 5 continents. The radio telescopes all collaborate to observe the same object, acting as if they were one planet-sized telescope. It is then up to the EHT experts to piece together the data collected by the telescopes to form a single picture. M87 was captured using the same approach. 8 EHT radio dishes spent a week studying the black hole in April 2017, resulting in months and months of labor to combine the data into the image that was finally released. At the same time, the EHT detected Sagittarius A-star. But creating its picture proved far more difficult and time-consuming. Taking a photo with the EHT is like listening to a tune played on a piano with a lot of keys missing. SGR A-star is smaller and less active than M87's black hole, and the material surrounding it is brighter, making it more difficult to view. Furthermore, when the particles around the black hole are driven to far greater energy, the material that does surround SGR A-star displays strange flaring. While it creates an intriguing light display, the makeup of the black hole varies every few hours, making it difficult to monitor over time. The material swirling around SGR A-star at the event horizon, the point of no return for particles going into the black hole, moves so quickly that the objects appear to change in real time. When the EHT scientists observed SGR A-star, they collected roughly 3.5 petabytes of data. That's the equivalent to about 100 million TikTok videos. A multi-layered cloak conceals Sagittarius A-star. The cosmic plane, 26,000 light-years of gas and dust that covers visible light, is the first stratum. The scattering screen, a turbulent stretch of space where density fluctuations in the interstellar medium push radio waves slightly off course, observes radio waves as they travel across the galactic plane. The blasted stuff surrounding the black hole itself is the final layer covering Sagittarius A-star. Peering through that barrier is like peeling the layers off an onion. Because the outer layers produce longer wavelength light, having VLBI operate with shorter wavelength light will allow for closer views of the event horizon. That, however, posed a significant technological obstacle. Astronomers employing techniques other than VLBI originally had greater success, gradually accumulating indirect evidence that the Sagittarius A star speck was in fact a raging supermassive black hole. In the 1980s, physicist Charles Townes and his colleagues demonstrated that gas clouds in the galactic core moved in ways that made sense only if they were influenced by a large, invisible gravitating mass. Gers and Genzel began separately studying the orbits of large blue stars in the galactic center in the 1990s, tracing their motion around a hefty but hidden pivot point. A few dozen astronomers and astrophysicists working in this esoteric part of astronomy agreed on the formal objective of establishing a virtual planet-scale radio telescope to view the shadow half a decade later. The EHT was born with the first official kickoff meeting for the project in January 2012. 5 years later, after expanding into cooperation of over 200 scientists from 8 collaborating observatories across the world, the team had its first realistic chance at spotting Sagittarius A star's shadow. Over the course of 10 days in April 2017, telescopes throughout North and South America, Hawaii, Europe, and Antarctica collected 65 hours of data on 1,024 8-terabyte hard disks, which were then transferred to supercomputers in Massachusetts and Germany for correlation. 5 years later, the ecstatic EHT researchers demonstrated to the world that their experiment was successful. This image is the work of decades. Thousands of scientists all over the world, despite technological obstacles and a pandemic, were able to release this image. So what do you think about this beautiful image? Let us know your thoughts in the comment section below. And don't forget to like the video and subscribe to our channel, and press the bell icon so you never miss out an update on this exciting story.